Section 1.6, we're going to split up into two pieces, so part A, part B. The first part is just compound inequalities. We're going to address some interval notation. So after we have graphed, we're going to address interval notation. So we're going to take this graph and write what are called intervals. Looking at our closed circles or our open circles, we'll determine if we've got brackets or if we have parentheses in our intervals. Obviously, a closed circle will be a bracket. An open circle will give us parentheses. When we are continuing to infinity, so when we have these arrows at the end of our graphs, that shows that we go on to infinity. So for this graph right here, we go on to infinity as our numbers become smaller. So our intervals come from negative infinity, smaller numbers, to -3. And this is combined with another interval that begins at 3, right here at this open circle, and goes on to positive infinity because these numbers become larger. And when you are having an interval with infinity within it, we will never have a bracket on it. That would imply a closed circle, but that would tell you exactly where a number is, but infinity does not have an exact amount or value. All right, compound statements, or these compound inequalities, you have either conjunctions or disjunctions. The giveaway to whether you have a disjunction or a conjunction are the words and or. We also have some implied conjunctions, which we'll go over. And when we do our intervals, you would have seen just a moment ago the union. And most of the time you're not going to see this intersection in our intervals. It's just going to be that little closed interval. So this would be an intersection interval. This is a union interval. And an intersection implies what solutions are the same or in common. And then union is we're just going to put these two solutions together. They're not really in common. We're just going to smush them together and take them at the same, not really the same time, but we're going to take them together. Okay, so here's some simplified solutions. Here is a conjunction. So x is less than 5, and we want x to be greater than -1. So here is the x is less than 5. We also want x to be greater than -1. So where do these combine, and where do these solutions satisfy both of these portions? Because they have to satisfy both of them. It has to be less than 5 and greater than -1. So we just put these two together, and all of these numbers are less than 5 and greater than -1. So 2 is greater than -1. It's also less than 5 at the same time. So this is an intersection. Here's a union. The solutions to a union can be either less than -2 or they could be greater than 2. So here's our portion that is less than -2. Here is our portion that is greater than +2. If we just put both of these pieces on one single graph, we can see this union. So 3 is definitely less than -2. It doesn't have to satisfy this piece because this is a disjunction. This is the union, the or. Okay, so let's actually solve a compound inequality. So we have -5 is less than or equal to 2x plus 3 less than or equal to 5. So what we do is we have to break this up. This is an implied conjunction. It has an and because we go from a negative number, a small number, which is less than our expression, which is less than our large number. So it's an implied conjunction. If for some reason we had written here, and they used to do this when I was in Algebra 2, they would have the large number less than the expression less than the small number. That would actually be a tricky disjunction, but you guys don't run into those very often. Anyway, so we take the expression, place it over here in our first portion with our first portion of what looks like the solution. So break it in half, and then we also take this expression with the upper half of the solution. So we have these two pieces that we're going to solve. So here's our solution. Of course, that doesn't look any different than solving the equations or inequalities. Canceling out the 3, dividing out the 2, and then, of course, we turn this around so we can see that solution. And the same for the other piece as well. And so then we would need to graph both x is greater than or equal to -4 and x is less than or equal to 1. Of course, you can pause this if you want to take a look at how the solutions came about. All right, so we needed it to be greater than or equal to -4, and we needed it to be less than or equal to 1. So they had to be at the same time. So this piece of the graph and this piece of the graph, they have to overlap. So we do not keep anything beyond the 1 from the graph that was greater than -4, and we do not keep anything beyond the 4 from anything that was less than the 1, because this is taken together, this is at the same time. A -1 is greater than -4 and less than or equal to 1. And of course our circles are closed in. So if we were to write an interval, these are closed, both of them, so we have brackets. This is not going to be neat. I'm not up at my board. So we have those brackets for our closed circles. Our numbers are -4 and 1. And since this is a conjunction, we know this is going to, that's a negative, kind of look like an ordered pair almost. This is that intersection. Okay, so -4, closed circle, begins at -4, goes on to 1, and it's a closed circle. So this is what conjunctions look like. They're very short intervals. Okay, here's an example of a disjunction, and it's very obvious. You have an or. So we're going to solve this piece and this piece. This or is not, oh, choose one. It just tells you you have a disjunction, you have a union. So of course, this is how we solve. Canceling out the 4 by subtracting, dividing out the 2. And we need to solve the other piece, which is slightly different expression. We got to cancel out the 3 by adding. We got to divide out the -2, which also flips this sign. We need to graph a piece that is less than -1. We need to graph a piece that is greater than 2. And those go away from each other. Here's less than -1. Here is greater than 2. Those go away from each other. There is no one single number, or there are no numbers that you could choose that would satisfy both pieces. We know that because we have an or. Okay, we have an open circle and we have a closed circle. Now, this interval would look like we're going from infinity, which always has a parentheses. Now, these are always fun to draw. It's a sideways 8. Now, this infinity is negative because these are the smaller numbers. It's heading towards smaller numbers. So we have a negative infinity. And it goes from the negative infinity. Here's our -1. Just like with anything that we do, we read left to right. So that's how we're going to write our interval. Over here on the left, that's the negative infinity. And then we get to the -1, which is a open circle. So we have another parenthesis. It's an or, so we're going to have a union. This is a closed circle, so I'm going to have a bracket. This number is 2. So I'm going to have a 2. Very pretty 2. Not on my board. And it's going on to infinity, continuing. So I'm going to have my infinity. And of course, infinity never gets a bracket. It's always a parentheses because it's not an exact value. And there's your interval. Just left to right. Okay, so I'm going to show you 2 special cases which are a little bit different. So here's what looks like a conjunction. You kind of know what that graph looks like. It kind of goes in between, stops at the 2. So let's look at this. So this is all solved out. Cancel out the 4, divide out the 2, we flip it over. We have x is less than 3. So it should go below 3. We cancel out this 3, we divide out this 2. This says x is greater than or equal to 4. What would that graph look like? Here's less than 3, here's greater than 4. It's supposed to satisfy this at the same time. Is there a number in between here that satisfies being less than 3 and greater than 4 at the same time? No. So this is no solution. Here's another special case. So it looks like we have a disjunction because our little clue here is the or. So of course here's what we've got it solved out. Cancel out the 4, divide out the 2. We're left with x is greater than -1. Cancel out our 3. Divide out our -2, which is going to flip our sign. So we have x is less than or equal to 2. So greater than -1, less than 2. Let's see how that graphs. Here's our greater than -1. Here's our less than 2. If we put those two pieces together, they totally overlap. Remember, union takes together everything from this solution, everything from this solution, puts them two together, and we just take them all. Take all those solutions together. We don't cut anything off. It doesn't need to satisfy both pieces at the same time. It can be either this solution or this solution. So if this takes everything and it all overlaps, we get all real numbers. We get the entire number line. So this is yet another special case. So we can have a no solution like this last problem because we cannot, satisfy both conditions at once, or we have the entire number line. So that's it for the compound solutions.